And so now you should have a good understanding of classic experiment design. The fact that microgravity experiment design is about asking what the role of gravity is in a system, that you want to put a flight experiment up in a weightless environment so it thinks that gravity's turned off, have a control experiment on the ground, and when they come down side by side, compare them to see if there are behavioral differences that provide the underlying role of gravity in what you're studying. Um, I, I provided you an understanding of mini lab operation. I gave you reasons for why 75% of the experiments are biological in nature. I gave you two examples at a middle school level and an undergraduate level of two different experiments. So now the next part of this from your vantage point is, okay, how do I come up with a microgravity experiment? How does my team figure out what kind of microgravity experiment we want to do? So there are 5 ways I can give you, 5 general ways. The first is you've got to read the mini laboratory operations page right out of the gate. The mini lab operations page is the operating manual for the mini laboratory, and it has all of the engineering and technology constraints imposed on the science experiment you're going to design. So before you go and start designing a science experiment, you got to know what the mini lab can do and what it cannot do. And once you know that, you can start working on your science experiment. You need the engineering and technology constraints first. So the first of 5 ways that you could come up with a microgravity experiment is you can look around your world and say, gee, I wonder what the role of gravity is in that. And I know that that can work in the mini lab because I read the mini lab operations page. So let me give you 2 examples. There was a middle school student that went down in her basement one day, and it was damp down there, and on an inside wall she saw moss growing on an inside surface, and she said, I wonder what the role of gravity is in the life cycle of moss. A high school student, a junior, had biology the year before, and she really liked the planaria worm regeneration lab. That's where that example came from. So she said, I wonder what the role of gravity is in planaria worm regeneration, and I know that that can work in the mini lab. That's where that experiment came from. So the first way that you can do this out of 5 is look around your world and ask what the role of gravity is in this thing over there or that thing over there, because I know that that will work in the mini lab. The second way you can do it is you can do research online to see what kind of microgravity experiments have already been done in space, and that can provide you some insight. A third way you can do it is you can go to the document library and download the microgravity science background document, which provides an overview of 9 separate science disciplines appropriate for microgravity research and why. And there's an accompanying case studies document that has examples of experiments in each of those 9 science disciplines. Science disciplines like crystal growth or protein crystal growth or microbiology. A fourth way you can do it is you can download the microgravity samples document, which lists hundreds and hundreds of fluids and solids that are used for microgravity research and why, which can give you ideas for a microgravity experiment. And a fifth way you can do it is you can go to the website and read a 1-paragraph summary of over 440 SSEP experiments already conducted in the mini laboratory. And as I said, there's a page dedicated just to all of the undergraduate experimentation on orbit through SSEP. And if you get ideas for an experiment by looking at all of those summaries, you can do an experiment over again if you want. If you want to do an experiment over again, you can. If you want to do an experiment that has been done on SSEP, but a little differently, you can. If you want to come up with a whole new experiment that's never been done and hopefully add to the human book of knowledge and do scholarly research, you can. Here's the important point. Your deliverable is a formal proposal written from the proposal guide, which is the template for a proposal. And in that proposal, in the first section, you have to explain the proposed experiment, and you have to provide a justification for why you think this is a good microgravity experiment, with embedded citations in the text and a bibliography of primary references. You have to provide a section on procedures. How is the experiment going to be conducted in space? How is it going to be conducted on the ground? If you have trial data that you've run trials in test tubes the same size as the mini lab, that trial data should be included. And you have to have a section on analysis. What kind of analysis are you going to do to see if you answered the original essential question, the original hypothesis that you put forward? And you cannot get a full proposal from a one-paragraph summary on the website. Can't do it. Now, there are no proposals on the website. We do not give you a proposal. That would be a roadmap. You have to come up with the proposal yourselves, written from the proposal guide. So does everybody understand that? So again, 5 ways to think about what kind of experiment you want to do. Look around your world and see if there's something you're interested in doing in the mini lab. Second way, internet research. Third way, download the microgravity science background document from the website. Fourth way, download the experiment samples document from the website and see hundreds of fluids and solids to give you ideas. Fifth way, go to the SSEP website and read up on a lot of experiment summaries. So everybody got that, right? All good? Okay, so now are there any questions before I move on to website navigation?